Yeah. Okay. Good evening, and it's about the time I'm gonna go ahead and get this started. And then I was talking to Brick, and then I was telling her that I think that I made a mistake that the homework 3, it's available. Okay, when I check that one in order to see that whether you guys have turned in homework, then all of a sudden I saw that it's not been made available for you guys to go ahead and do the homework. So that I'm so extremely sorry for that one. And then I really apologize for that one. And then I'm going to give you more time for you guys to finish everything and then turn in pretty much including whatever all the work until next. I mean, like this is the not the next week. I'm talking about we're gonna have a this is the third week or this is the fourth week. I'm sorry, this is the fourth week today. Yeah. This is the last week. So I'm talking about that when you're done with all the final exam and everything, I'm expecting you to finish everything, including homework 3, 4, quizzes and everything until next, not this coming Wednesday, the following Wednesday. Until following Wednesday, I'm going to give you more time for you guys to just to finish everything. So I'm extremely sorry for that one. Then I all of a sudden that I made it available, even homework 4 as well now, because I thought of going week by week and then make it available, but anyhow, last week it didn't happen. So this is the last week. So pretty much we have to cover chapter 7, and chapter 7 we can spread out and then cover today and then Thursday, because that's the last chapter we have to go through. And plus that when it comes to final exam, it seems like because you know that as I mentioned in the very beginning, all these homework quizzes and everything being structured by the college, so that we don't do anything being added to that one. It seems like that if you go ahead and look at that the final exam, it seems like the data file is not over there, instruction file is not over there, exam is not over there. So in that sense, what I'm gonna do, you just do that chapter 7, which I'm gonna cover this week. Chapter 7, because since we don't have a homework, chapter 7, chapter end review questions can be counted towards your final exam. I'm going to take that one as a final exam. Okay, that's what I'm going to do, because I saw that I didn't see that final exam. I thought that when I'm going to make it available, it's going to appear that it seems like it's not there, it's missing. So the data as well as the instructions for the final exam missing. So in that way, I'm gonna make that chapter 7, chapter end review questions as the final exam. Okay. So any question on anything before I'm gonna go ahead and get started? Anything related to homework, quizzes, and this final exam, midterm test, anything? If you guys wanna discuss anything, we can discuss right now or then after the class. So doesn't matter. Okay. So if not, okay, so everything's clear now. Okay, that you have the homework 3. Homework 3 is all now. I made it available, plus homework 4 and final exam. And we don't have any quiz for this week. We have a final exam. For the final exam, I have converted the chapter 7 and the review question as that whole set of questions as the final exam. Okay. When you do that on your side, that I can easily, I have shown you that one several times, that I can go ahead and then get the information and see that whether you have done or not. Okay, make sure do not procrastinate anything, just to make sure. But I'm going to give you time all the way up to the following not this Wednesday, up to following Wednesday, to pretty much finish everything. Okay, because next Monday I had to start the continuation of this course, the second part of this one, which is 605, ANS 605. Okay. Okay. If you don't have any question related to homework, quizzes, midterm test, final exam, or anything, any material, coding, or anything, just I'm going to go ahead and then get started chapter 7. Okay. Before that, what I'm going to do, I'm going to go ahead and then share this one. Okay. Let me see. I see you. Yeah, I'm gonna share the screen. Okay, in chapter 7, what we're gonna do that up to chapter 7, we were talking about the empty model. Empty model means like we have a y variable of interest, okay, variable of any interest. We that discuss that one with the aid of its own mean. Now in this chapter, what we're trying to do is that we are systematically adding an explanatory variable. Explanatory variable. Can you remember earlier in the very beginning we were talking about we have y and x. So y variable being explained by the x variable, but in the very beginning, in chapter 5, 6, that we decided not to include any explanatory variable to explain the y variable. Y just being explained only by its own mean. Okay, but at this stage, what I'm gonna do, I'm going to go ahead and add an explanatory variable. As you know that explanatory variable can be either quantitative or qualitative. Okay, so in this stage, this last chapter, what we're going to do, we're going to add a qualitative variable or categorical variable. Okay, only categorical variable will be added to that model in that way that you can explain the y variable or the response variable with the aid of that categorical variable. Let's say that for instance that thumb length can be explained by the gender. Okay, for a male and female, see that how it's going to affect to that thumb length or how they vary from each the two groups. Okay, because of that one, sometime we're going to call that one a two-group model, because since that if you have a two groups, we call the two-group model, but this is categorical. I'm talking about the explanatory variable. Even under the explanatory variable, I'm going to take the categorical variable at this stage. But in my next class, in the very beginning, what we're going to do, we're going to add a quantitative variable for explanatory variable. Explanatory variable would be quantitative at that stage, and then we're going to explain that one in different way. Here, the response variable or our yield or that result will be explained through an explanatory variable which is categorical. Okay, that's what we are planning to do over here. See, having explained the variable, having started with the empty model. Empty model we can remember, null model. You may be feeling frustrated. Okay, statistics we said that is about explaining the variation. Okay, it's about explaining the variation. But in what sense we have explained variation with the empty model? See, yes, the mean is the point in the distribution that reduces the sum of squares to its lowest point. You can remember we had a broader discussion with respect to this guy. We were talking about that if you know this is nothing but the average of this particular distribution or this data set, then we got the mean, and then if you go ahead and check each and every data points, they are just away from the mean by a certain distance. That distance we refer to as the error. See, error. Then how that can be minimized? That can be minimized if and only if that if you're going to take this line or the average as your reference line. You saw that one. We explained that one. We took another point and another line, and then we had a discussion, and you saw that when you're gonna take those deviations or the residuals or those are distances between the point and that particular point or the line, and then we square them and then we sum them up, and then you saw that sum of squared residual with respect to mean is the minimum value when we compared with those SSR being taken with respect to another point or another line, which is drawn at a different point. Okay, and we discussed that one. Okay, so see, empty model, but see the distribution that reduces the sum of squares to the lowest point, but surely that doesn't count as explanation. It's not enough for us to move forward, because that we simply say that our error has been minimized with respect to the mean. That's not enough for us to explain our model. Indeed, it does not. We started with the empty model in order to get some important ideas across, but certainly that's not where we want to end up. It's time we start building models that include explanatory variable. Actually, This is the whole purpose of that built-in of the model, because we explaining one variable through another variable. But in the beginning, we didn't throw any variable for our model. What we did was that we explained y variable by its own mean, but it's not enough. That's why we are planning to include an explanatory variable at this stage, which is a categorical variable. Okay, we still use the empty model, but only as a reference point. But still we use, but as a reference point. Okay, let's start by reviewing that we mean by reviewing what we mean by explaining variation. Early in the course, we develop an intuitive idea of explanation by comparing the distribution of one variable across two different groups. So for example, we look at the distribution of thumb length broken down by gender, which we can see in the two density histogram below. See, one for the female, the other one for male. We can remember that we did the graphical representation for, or graphically we had this discussion. As I mentioned in the very beginning of this discussion, we had graphically. Now we are trying to explain the same phenomena through a model. That's it. We saw this one with this broader discussion we had earlier. See how to represent them graphically, how to draw the graph for male and female, and how to compare and contrast. Those things we did that with the aid of all these graphs. Now what we're going to do, instead of just looking at the graphical aspect, we're going to look into the mathematical or statistical aspect or the model aspect. Okay, that's what we are trying to do over here. You can clearly see that this, the gender explains the sum of the variation in the thumb length for sure. See, we can break up the thumb length by gender. It looks like two separate, though overlapping distribution. In general, males have longer thumb than female. See, that's for the male. See, look at the average. Look at the average. See? You can compare and contrast. See, and then see, pretty much they both have like a similar kind of, but some parts are missing here. So you see, if we assume that the relationship between the sex and the bum length exists in the population and not just in our data, we can use it to help us to make better prediction about the future observation. If you know that someone is male, you would make a different prediction of the thumb length than if you know they were female. That's why we are trying to build up some kind of a model. Look at this time. This time we're going to include that, not y bar anymore. We don't have y bar. Can you remember? This is y. Last time we have y bar plus other stuff called error. Now I'm systematically include an explanatory variable which is categorical. In this example, it's going to be gender. See, I'm including that one to my model now. But see what this says. It is the gender explains some of the variation in thumb length, but other things also affect the thumb length. Other things also affect the length. Building on the previous, I mean, like if you have one variable or two variable, other variable you can keep adding. All the categorical variable you can keep adding. Other explanatory, other quantitative variable, if you can keep adding, and then mixture we can keep adding. But at this primary stage, in order to lay down a good foundation for what's going on, when we include an explanatory variable, we're gonna just stick to only one variable, one explanatory variable at a time. See, it's a simple model. See, it's not a, if you have two variables on this side, two variables gonna explain the thumb length, then you're going to call the multiple model. But fortunately, we don't have that kind of multiple model over here. We have only one variable, which is gender, going to explain the thumb length. Okay. In the beginning, thumb length being explained by its own mean. That's one model. It's called an empty model. Empty model will be utilized at this stage as a reference model. We need that one. We need that one because we're going to see that one down the road when we run some kind of a statistical procedures, how that empty model is important. Okay, how that everything has been sprung from the empty model. Okay, so now we add this one. It's a simple model, but we have added categorical. Okay, so see, empty model. If you go ahead and talk about the empty model, has a different ways of explaining. We talk about this one in large scale. Okay, So you can remember, see, each person's thumb length being given by y. B0 is what? See, B0 is nothing but, in the beginning, nothing but the mean of every thumb length. You can remember that's the mean, okay? And this is the error, you can remember, okay? So this is my y thumb length. This is the average thumb length. This is the same thing we gave in a different ways, okay? In the empty model. In empty model, we gave those in so many different ways, okay? That means I'm gonna write something here for you to see clearly. Yeah. So, so we were talking about the empty model, you see, empty or null model. In the null model, we had y equals, see, plus we have a data equals model plus other stuff. You can remember. Then data given by y, this is given by y bar. This is called the error or residual. Can you remember? If it is sample, we call residual. If it is population, we call that one error. And then same thing in the sample setting, we had that discussion, assuming this is for the sample, okay? I'm gonna call this one for sample. For the sample, for the sample. The same thing we call the B0 plus E. And same thing we explained by y hat plus C. See, you can remember. That's the model, see. So all our models, same model, being given in different ways. See? So B0, y hat, y bar means the same thing. That means B0 means the average, okay? Average. See? In the case of the thumb length, this model states that the data, each data point represented as a y, and then see, we can remember we had that discussion, okay? Then when we use the notation of general enemy, we must define the meaning of each symbol in context, okay? Y, for example, could mean lots of different things depending on what outcome variable is, but we will always use it to represent the outcome variable, Y for the outcome variable for sure. See? So let's say that it's useful to illustrate the null model or empty model with our tiny fingers data set. You will recall contains 6 people thumb length, 3 males and 3 females, randomly selected from our complete data. See? Tiny fingers. See? It's a gender, it's a thumb length. See? We could represent the distribution of 6 thumb lengths broken down by gender using a faceted histogram left panel below. Or we could use a scatter plot as shown in the right panel, see? With, which might be clear with such a small data set. See? You can show like this way. That's a one way of showing that one. Faceted, see? Scatter plot. This one is a right side scatter plot. Thumb length. This is for the female. This is for the male. You can remember how we drew this one. You can very clearly remember there are all the codes and everything, okay? R codes and everything you can remember. And same thing we can just do with like a aid of faceted histogram for the males and females. I'm going to draw the histogram. See? And it's been arranged in vertically like this way, okay? See, you can remember. That's a graphical representation, okay? See, you can see in this histogram on the left below, a bar has been circled. Identify the corresponding point in the jitter dot on the right. See, this one, this point is definitely for, we can say that it's definitely for what? Which one? Around like a 60. See? Which point is that one? That's why they say that identify the corresponding point in the jitter plot on the right. See, this is one for the female, this for the male, so you have to go to male for sure. So which one? The first one, see? This one has only one. See? At this level, this value has occurred only one time. This value has occurred one time. This is second value has occurred one time. See? That's why it's been represented by E on the jitter plot. On the histogram, it's represented by bar. See? The point, see, look at the two different graphical representations. Sometimes we use a bar, sometimes we use just simply a dot. See, this represents this guy. The similar fashion, this represents this one, this represents this one, this represents this one. See, like that. But they were asking the circle one gonna represent what? It's from the male group. In the male group, there's a second data point. Let's say that you have another, that this has been added another one. There are two data points for the same value. See, same value is two data points. But still it's going to fall over here. But they are distinguishable, okay? But see, you can clearly see at the same height, but as another one, a little bit close to that one, okay? But here it's going to be stacked on top of this one to show that there are two data points for that particular data value, okay? See, look at this one. Now look at that, what they're trying to do. The same thing, you're going to take out the scatter plot. See, the scatter plot below, the grand mean of the distribution, ignoring gender, is represented by the blue line. You can remember for the first time, this was the grand mean. Grand mean for that, regardless of the male or female, you're going to add all the data points and then divide it by number of individuals. That would be give you the grand mean. Now separately we have for the female this side, male for that side. See, we saw that one too when we were drawing this, all the graphs, scatter plot or jitter plots. Okay, we saw this one. See, this is this person actual thumb length starts in the same value as y1. See, y1. See, E1, the deviation between y1's thumb length and the prediction empty model. See. Then V0 is a prediction from the empty model. See, let's see what they're trying to say more clearly here. Look at this. You have a male, this is a grand mean. Then you have a 3 points. You can get their mean. Their mean is 65 for the males. For the females, somewhere here, maybe 59. See, somewhere here, see, that's the mean for female. So if you go and y1 deviation from the female means, see, X model. Is see, if you're going to do this one with respect to this line, if you do this deviation, if I'm going to check the deviation, regardless of the male or female, I'm not going to talk, I'm thinking that I don't have any explanatory variable not being included, like a gender not being included here, but still, once you go over here, you know that whether this person is male or female. See, so here what we had done is that we have that organized the female dots to one side and the female dots to the other side, and they were telling that if we don't have this red line and this one, if you're going to do this consideration of this deviation, if you measure with respect to the grand mean, that is what we are doing in the empty model. That's what they say. In the empty model, we are doing like that. We go over here with respect to the grand mean, you take the deviation. Go over here, deviation. Go over here, deviation. Go over here, deviation, deviation, and deviation. And you know when you get the deviation, when you add them up, they're going to add to 0. That's why we're going to either take the absolute value of that particular deviation or square that one. See, here these three are below the average, below the grand average. Actually, we're going to use that one because that now there are two more averages over here because of that one, to distinguish that one from the mean for males and mean for females. We're going to call that one grand mean. Okay. So these three are above that one. See, we're gonna square that one, and then we calculate the sum of squared residuals, and we did a lot of stuff over there. Now that's, if you do that one with respect to that guy, come into one. Instead of that one, if you're gonna consider their own group, you go inside your own group. It's called the within now. Within the group, this is called the deviation within the deviation. The residuals within this female group, within this male group. If you want to find the deviation again, what we're going to do in our that new model, or this gender model, or we can say the two group model, there are two names, two group model or gender model. What we're going to do, I'm going to go ahead and take a deviation of that particular guy with respect to my own mean within that one, not the grand mean. See, I measure this height, this deviation, this residual, see, this distance, and so I'm going to pretty much do the same thing for this one and this one. And if you do like that and check for the deviation, that's called that the deviation coming from that gender model. So same, pretty much a similar fashion you can do for the males as well. See, that's the deviation of this point away from the mean from males. This is the deviation of this point away from the average male's average, like that. And the third point, this one the same, we can measure that one. Okay. As I say, you still measure the same way as the deviation of each person measure. See, you can see here they were asking about that each array still measure the same way as the deviation of each person measured thumb length from their predicted thumb length. But this time the error is calculated from each person group mean. See, it's called the group mean within. This is the group mean. See, female group mean, male group mean. See, that's why they say this time the error is calculated from each person's group mean instead of from the grand mean. This time it's being measured with respect to their own group. Grand mean, if you take with respect to grand mean, we're going to call that one down the road. That's the total variation. That's why we are trying to add another new terminology for that, some new stuff. Okay. So now if you're really looking for the deviations, see, so the error is how much the error is with respect to only this curve, not with respect to this one. It's a kind of error too, but we're going to say that's a total deviation. See, then not only that, we're going to then later on say that how each mean is away from the grand mean as well too. There are three things. We're going to try to put the three pieces together over here. One thing, if you go ahead and pick up a point and see this is how far this is away from this own group. Okay, you can do that one for the male group, female group, and then you can do that one for the male group as well. That's the one. Pretty much a similar fashion, without regard to that, we have this gender, it's been separated with respect to the gender. You can simply say we have 6 individuals. I'm going to say that how their deviations are with respect to grand mean. If you can do that way too. So the same point. See, I did the deviation with respect to that guy. I'm not going to do the deviation with respect to this guy, and I'm going to do another one. I'm going to see the deviation of this guy with respect to grand mean as well. Now I'm going to take the difference between two means as well. I'm talking about two means grand mean and group mean. Group mean at this stage, the female. So some similar fashion, you can find the group mean and the grand mean difference. See? And at the same time, you can find the deviation of this point away from the grand mean as well as from this one. So there are three things we are doing over here. The deviation with respect to group mean, deviation with respect to grand mean, deviation of group mean with respect to grand mean. Okay, three things we're going to try to tackle over here. Okay. On the jitter plot above, which distance is an example of error from the empty, also known as null. See, null model. See, the jitter plot above, which distance is an example of error Which distance? They have given distances between two means. No. They have given the distance from the grand mean to that this group mean, male group mean, and they have given the distance from here to here. See, another one they have given from the grand mean to this one. See, see, see. But this time the error is calculated from each person group mean instead of from the grand mean. See, see. The distance is an example of error from the empty model. This I'm talking about the empty model, not this model. In an empty model, we are doing error has been measured with respect to the grand mean, okay, of the point, not the mean. See, that's in the empty model, not in this model. If it is in this model, what would be an error? Error would be not this one, not this one, not this one. Error means any distance, any deviation with respect to their own mean. It's a deviation. That's why they say it's a group mean. So this is a residual. See, this error is the residual. This error, they were measuring that in the empty model, which is called the total deviation. These are the total deviation. These are the deviation due to, see, this model called the sum of square residuals. These would give you, if you're going to square and then add together, that's called the sum of total sum of squares. Total sum of squares. Total sum of squares. Okay, that's what I'm trying to do over here. But we're going to build up that one piece by piece. Okay, look at the figure above. Is the deviation of y1 greater from the empty model or from the sex model? See, y1. See, which one has the more deviation? See, see, look at the figure above. It's the deviation of y1. Y1 they call this one. See, y1. Okay, y1 greater from the empty model or from this gender model. See, which one give you that greater model? Empty model. See, this is the empty model. If you're trying to empty model O with respect to grand mean, deviation is way high. See, then it's being measured with respect to the group mean. Or in the empty model, this deviation is see, way high than in this gender model. Gender, or you can say two group model, since we have only two options. If it has like a 3 option, 3 group model, 4 option, 4 group model like that. Okay. See, from the empty model, because the distance from the grand mean is greater than the distance from the mean for female. See? Distance from the grand mean is far more than the distance from the mean for females. That's why. You see, this is the place. Now we're going to include that one by this. You see, this is the setting. Now instead of B naught, I'm going to include another one, another variable x, and it's been even that given by B1. This B naught, and B naught has in empty model, B naught has a physical meaning. B naught is nothing but the average of y. But at this stage, it's not the case. Let's see what it would be. Okay, what that would be, B naught. Okay, see. Yeah, I'm going to introduce this model at this stage. Okay, so what I'm going to do at this stage, very clearly, I'm going to come to again sample model. This is empty model, first one. Then the second one, I can say two group model. Or you can say this one, for this particular model, you can say gender model. You're going to write your data. See, you're going to write data. You're going to write the model again, plus other stuff. It's same, stay the same. But only difference, the model going to be not the way that we wrote over here. I'm going to write systematically B naught first this way. See, that's the model for this one plus error. See, let's see physically what this means. Okay, but we are at this stage. we're gonna just go with this one. Remember, this is categorical. Categorical. Remember, this is quantitative. Font. This cat. Okay. Scat. Then let's see what B0 and B1 represent. Okay. That's what we have to look into. See, that's the new model. The new variable has been introduced. Okay. So that's why they say that. Okay. This would be Y would be nothing but the data. This whole thing is the model, as I mentioned here. See, the whole thing is the model. This whole thing is the model. Okay. And E is the error. See. See. You can say Y is nothing but the thumb length of each person. This whole thing is what? The prediction of the thumb length. Model means the prediction. See? So, see? The same way over here, you can add another one. See, Y equals prediction. See? Prediction plus error. That's the same thing. See? In a similar fashion, for this new model, the two-group model, I can say Y equals, see? Prediction plus error. See, your prediction is nothing but B0 plus B1 X. See, that's the prediction. Last time the prediction has been given by B0 only. See, or Y bar only. See, Y bar B0, that's the same thing. See, you can call it Y0. Y bar, B0, Y hat, or predictions. Those are the predicted values. See, that's the error. See? If you're going to explain that, give a physical meaning for that. Now you see, now let's go ahead and see that what we can get over here. See, in a two-group model, the model statement we wrote like this: the model statement. Let's say if B0 represent the mean for females, then B1 represent represent what you would add onto the mean for females in order to get the mean. See, that would be what you have to add to the mean for females in order to get the mean of the mean for females. How much do you have to add to the female in order to get the male of the average of the males? That's called the B1. So they have a physical interpretation, physical meaning. So what this is what they were talking about. So they were talking about, this is exactly what they were talking about. So they were talking about, then they have like this. Okay. They have a grand mean. Okay. This thumb length. Here we have a now this is Y. Y is nothing but thumb length. Now we have X. X is nothing but gender. See. Then you have a female or male. See, types. And then see, if you go to this one, it's gonna be how much? Okay, let's see how much it's gonna be. 60, 59. See, female 59, and then 59 has been added 6. See, increment is 6. So then. And I'm gonna see that grand mean as well. Let me see the grand mean. How much would that be? Is that given 59, 6, 0? We don't have that one, but that's okay. I think that should be 62 if I'm right. Okay. This one, the grand mean. See, Y bar. That's the grand mean. So I'm gonna have over here, see, Y bar for female. I can write like this, that way. Y bar for female, Y bar. And here, Y bar male. See, This one. So this one is the value they're gonna say B naught. This is the value they're gonna say B1. That's B1. The B naught is nothing but initially you can consider either male or female's average. See, you're gonna consider somebody's average. See, this is nothing but y bar, not y bar, y bar f. See, average or mean for females. So this one, average or mean for males. Then the gap between, then how much do we have to add to this female's average to get the male average is called the B1. B naught is what? Simply that the reference line that B naught is that female average. So in this particular case, how that can be explained through a this model. This model means like a y equals 59. They say this is 59. This is 59. Nothing but 59. So this one is nothing but 59. And they have added 6 units. So when you had this one, this become what? 65. I think this one is 62, if I can remember. The grand mean is 62. See? Male's average, 65. Female's average, 59. The gap between that one is, in this particular model, the B1. See, that's the physical interpretation. See, B1 is 6. B naught is female average. Then when x equals, let's say that how this gonna work. The equation, how it's gonna work. See, how the equation's gonna work. See, if B naught, if two-group model, the model statement still represent the person's predicted thumb length. This is a predicted thumb length, the whole thing as I mentioned over here. Not only B naught plus B1x would represent the prediction or the estimated value. But in this case, the model makes a different prediction for each person depending on their the gender. See, prediction plus error is equal each person actual thumb length. See, depends on that which group they belong to. Let's unpack the GLM notation to see how it generates the two possible model prediction. In the two-group model, B naught no longer represent the grand mean. See, remember, it does not represent the grand mean. You know that, okay? Make sure. See, it does not represent B naught. The grand mean, B naught does not represent this. It represents the mean for females. Okay, or males of the way that how you're gonna set it up, but instead represent the mean for one of the groups. See, one of the groups. Okay, doesn't matter which group you're gonna consider as like this one. Okay, B naught. For example, B naught might represent the mean thumb length for females, which is in the tiny fingers data 59. See, that's 59. If B naught represent the mean for females, then B1 represent the what you would add on to the mean for females in order to get the mean. Okay, for males. As such, B naught would represent the difference or increment in means between females and males. See? That's the increment between males and females. This is the increment between males and females. See? See? That's the increment. See? Increment between males and females. So, such a thing. In the tiny fingers data, the increment is 6 millimeters, meaning that if you add 6 millimeters to the mean for the females, you will get the mean for the males. Yeah. Here's how would we rewrite the model, include the essential parameters. See, this is how you're gonna write it. So at the end of the day, if you know the average of males then I can write this equation with the aid of my numbers. I'm not going to add anything to x or y. You're going to keep y as it is. If you know the b naught, which is in this case, b naught plus b1 x plus e. If you know b naught, which is 59, and then if you add b1, which is 6 x plus e, that would be your model at the end of the day. Y equals that model actually. See, you knew these two. You have, see, those other. You got the estimated value for b naught. You got the estimated value for b1. That would pave the way for you to get the estimated value for y. See, for a given the gender. See, so you're gonna write that one in this format. See. Now let's see how these two parameter estimates work inside the overall model. See, like this. See, B naught. B naught means mean for females. B1 is the deviation from the mean of females to the mean of males. You know, that's the difference between two means. Okay. You know, why does the X include sub I? Sub I means like for an individual, okay, for each and every individual, ith individual. This for the ith individual, this for the ith individual. Parameters never, these are called parameter. B1, B0. There are two parameters in this case. There are two parameters, okay? Two parameters. To make it very clear that what we are discussing over here, I can show you that how they come into the picture. See, as you know that always we have a population version and a sample version, okay? In a population version, your model data is model plus other stuff, you know that. And the model y, model is nothing but data plus model is beta naught plus beta 1x, okay, plus epsilon. You can remember how we wrote that. That's the population model. This has to do nothing with our sample. This is not the sample model. Actually, this is very abstract, theoretical. This is how you got the sample model. But anyhow, this one is the way, or you can say y equals y hat plus epsilon, where y hat is nothing but b naught plus b1 x whole thing. If you come to the sample, again you have a data and the model plus other stuff. See here y, so here you give that one by b and naught and b1 x plus e residual. See, or you can say y equals, see, sorry, this one, don't use this y hat here. I think it's not a proper way. This one I'm going to take out. No, just leave as it is. I'm going to call this one y hat for this part plus c. That's the estimate notation. Y hat is b naught plus b1 x. See, if you need the estimated part of y, it's given by this one. See, that's the estimated part. If you know b naught, if you know b1, if you know the gender can take, you see, where you see either 1 or 0, see, based on how you're gonna look at it. Okay. See, that's this one b naught and b1. We explain that one. Sub I we're gonna put to that, get the individual. See, because sub by the for variable like thumb and an error that have different values for different individuals. That's what it says. Okay, because the parameters are the same for every single person. See, so these are parameters. Actually, see, b naught and b1 are the parameters. So here beta 1 and beta naught. Here these are called statistics actually. Because already you know their value. Okay, I explain this one. Okay, sorry, we are no here. These are parameters. B naught and B1. I'm talking about. V naught, beta naught, and beta 1. Your statistics mean V naught and V1. That's what they were talking about here. If you were predicting a female, what's the only value that would change in this model? See, X is a fix. It's a parameter value. See, it's already estimated. Now we call statistics. It's estimated. Now you need the estimated value for Y. You need the estimated value for beta naught, which is B naught. You need the estimated value for. You can estimate, okay, by running that program. Once you give the data and run, the program gonna automatically run and then give you these values. Okay, these values they're gonna give you. You know that one. Not the value for this guy. These are variable. This is variable. This is a variable. This is a Y variable. It's a quantitative variable. This is a variable. It's a categorical variable. And this is a parameter, which is B1. This is B naught. They were already estimated through that procedure. Instead, this is B naught is an estimate for beta naught. You know that one. See? So you can simply say this one. B naught is an estimate. See? B naught is an estimate for beta naught. B1 also an estimate for beta 1. So B naught plus B1x is an estimate for beta naught plus beta 1x. We don't do anything with these guys. We don't need that one. We play with this one. These are the available ones. That's why these are called statistics. Statistics. They come from sample. These are called, see, parameters. Parameters. See, those are in the population. They are unknown and fixed. Here, known. We know that B0 and B1 we know, and varying. What do you mean by varying? Known means what? We know that in that particular sample, we can remember that this one is, we say that 59. Can you remember? It's known. We don't know about this guy. We don't know. We don't know. That's why we estimate. This guy we know. See, B1 is 6. We know. We don't know anything about this guy. Don't know. Then we know this one. If the X value has been given, we know. But even with the X value has been given, we have no clue about this one since we don't know about the beta naught and beta 1. Okay? So everything related to the sample. The population setting is only for the abstract part to build up the model. Actually, this model comes from this guy, from the population. You know that one. Like a sample coming from a population. Pretty much similar fashion, this model, population model is coming from, sorry, the sample model is coming from the population model. It is an estimate for this guy. This is an estimate for this guy. How could you gonna get the 6 and 59? The way that computer has been programmed with this R programming, that it's gonna just give us these two as output. Okay. Why it's gonna be varying? If you use another one, another data set for the same scenario, same number of data points, it's not gonna give the same number. It's gonna different because our data values are different. That's a different discussion. It's a very, that's why statistics become very heavy at the end of the day. But for time being, for a given sample, your sample, these are fixed. Okay, if you pick another sample, but here population, no matter how many, there's no such thing called the how many number of population you're gonna pick. There's only unique one population for that particular scenario. That population is fixed. Okay. Predicting the female, what's the only value would change in this model? X. If you change the X, and by giving the value for X either 0 or 1, see, you can easily get the female value. So that means if I go back to this one, and then this is my model now. Okay, this is my model. So I was looking for this guy. Okay, and then through the estimated or predicted, I got now y equals b naught plus b1x plus e. Then at the same time, I know the value of 59. This is 6 plus e. Okay, this is my model, final model. Now, if you want to know the average of females, I'm going to say when x equals 0, that for females, I'm going to use x equals 0. What do you get? I'm going to plug in this one here, plus 6 times 0, okay? Plus error term, you can think about that, okay? Plus error, okay? Just this part, model part, okay? You can consider only the y hat part. This is called y hat. I'm going to drop this one. You don't need this one. You can add that one anytime you want, okay? I'm looking for y hat part, estimated part only. See? So then you get what? Y hat is nothing but 59. This is nothing but y bar female. See? Know that. It's nothing but b naught. Same thing. Okay? When x equals 1 for males, I'm going to get the y hat part 59 plus 6x. I'm going to write here y hat 59 plus 6x. Then y hat here 59 plus 6 times 1, which is 65. This is nothing but not v1. This is nothing but y bar m. See? So that means that's how this model works. See? You were looking for this guy. You cannot access any of these. These are very abstract. These are very empirical, theoretical. See? These are very theoretical. This one, see? This part very theoretical. Theoretical or abstract. This part is very empirical. Empirical means practical. See, that's what you have in your hand. So based on that, our data, they have given 59 and 6. 6 means the gap between that averages. See, that's what they're saying over here. If you were predicting female, what is the value that would change in this model? X. If you're predicting female, what would be X would be 0. See, as I mentioned over here, see, for X equals 0. I put X equals 0 for females. See, for female, what would be B not be? 59. We already calculated that. 59. See, 59 B not. If you were predicting female, what would be B1 would be? 6. We already know that. See. See. If you're predicting a female, what would be B1X? B1 is what? B1 is 6, X is 0, because of that 0 times 6, 0. Okay, that's how I get 0. See. So see, under this model, as expected, males would all end up with one predicted thumb length, 65, see? And female would end up with one thumb length, which is 59, see? So note that this does mean that you have a code that variable in the data frame in any practical way. R takes care of that for you. As long as R knows that the explanatory variable is categorical, it's a factor, you can code sex with the numbers you choose, see? 1 and 2, or 0 and doesn't matter. 1 and 2, 0, 100, or even with the words male and female internally, R will recode the value as 0 and 1. 0 and 1. Okay. So they're gonna say They take the first one. See, mainly that they're gonna take as a like you might be thinking why they're gonna that if it is a machine, how could we know that female's gonna be like a 0, male's gonna be 1? Why it cannot be? It happened the other way around. Why female's gonna be 1 and male's gonna be 0? See, why they don't go like that way? Because they in the way that it's been set up, they in alphabetical order. Most of the time, females see get the 0. That one. If you want to change that one, 0 to 1, you know how to recoding. Okay, recoding, you know everything we have done. Okay, so you know how to do that one. Select the appropriate position for each term. See, these are the ones. See this one. Predicted thumb length for a female. This is a predicted thumb length for a male. I'm talking about the predicted value. See, A. See, this one. What is A? What is B? See, what is C? What is D? You know, this is nothing but our model. Okay, this is nothing but the same thing. Okay, the same thing we were talking about this one. So we have a C. A the y v0 plus v1x plus they were talking about even the error. See, this is the one. See, actually that the proper way of telling the predicted means only this part, but they were adding that error term too because they don't take this one so seriously. They're gonna call the either whole thing not be error. It's okay. Only this part is the only this part would be your v0 plus v1 would be the predicted value. So here they call A for this one, they call B, then you have a C, then you have a D. So this is going for v0, this is going for this one, this is going for this one, this is going for that one. Female, see? The same way that, see, you have a, see, v0 plus v1 x plus E, then they have given this setting E plus fg plus h, which is error. This is this one, this is that one, this is that. See? So that means, see, A means mean for females. Mean for females. See, that's nothing but another way of writing this one. You can remember what b0 is nothing but y bar f plus y bar f. See the gap male minus y bar f. See, can you remember? This is, you can remember, this is 59, this is 65, this is 59. See that gap if you want to look in that way, or simply you can put that whole thing like a, see, same thing, write that in that way. And then x, for x you put 0, can you remember, and plus c, like that. Okay, so I'm not gonna write too much over here, just leave as it is, and then and this one. So A, see, A for that one, A is the, see, mean for female, and the B is the, this is B0, simple B0, simple B1, B1 is the gap. See, difference between male and female means, that's the same thing I was writing over there. And then C is what? You're gonna, for C means X, for X you're gonna put 0, D means error. Okay, again, mean for females, so sorry, mean for male, oh no. Okay, this is a predicted thumb length for a male, this should be E. Difference between the male and female, see what, this one, see. Make sure. Okay. how that works, make sure. Okay. So if you look at this one very carefully, you can see something. This B naught here and here, the same. B1 here, here the same. But X not the same. That's what I want to tell you. See, that's what they are trying to tell you. See, for the females, you have a B naught, okay, which is 59. I'm gonna write like that, plus B1, which is 6. See, and X, which is 0 plus 0. And if you go to males, Y equals B not the same. 59 not gonna change. See, that's what they were trying to say. B1 not gonna change as well. And X gonna change. That's all. See? So that means A letter and E letter the same. A, E the same. A and E the same. See? A is number, see? Number 1. E, number 5. See? Look at the number 1 and 5. See? They're both the same. Mean for females, mean for females. It's the same letter. See? Doesn't matter. They appear in a different way. See? So this is A. This is E. See, look at this one. This is B. This is F. They're both the same. Look at this one. This is C. This is G. C and G different. See? C and G different. See? C would be that 1. G would be C would be 0. G would be 1. And the last one is what? The letters D and H. D and H the same. See? Look at this one. This is D. This is H. See? That means A and E the same. E and E and same means like a 59. See? And B and F same 6. C would be 0. G would be 1. D equals H equals E. See? That's what they are doing over here. See? See? The answer question R doesn't know. It's just taking whatever group comes if it making 0. The taking the next group and making it the female group comes first in the, because it is alphabetical before male. See, that's the only way that he knows, as I mentioned over here. Because you might be thinking that why only for the females they're going to take the 0, because of whatever the number, whatever that word come first come, first serve, they're going to automatically assign that 0 for the female because of the alphabetical order. Okay. If you want to change that one, you can change that one too. Okay, right there. But you see, let's say that just for fun that you could male as 0 and female as 1 in your case. In that case, best fitting value would be B0 would be the mean for males, which is 62, because this is not right. Okay, 62. Because the males are coded as 0, X would be equal to 0, so you wouldn't add the second parameter. See, you would not add the second parameter. See, for example, that would be mean B1 would be added on 62 to get the model prediction for female. Notice, however, that note that, see, 62 minus would give you the 56. See, look at what's going to happen over here. And that in this case, B0 would be the mean for female, which is 62, because the males are coded as 0. Okay, males are coded as 0. X would be equal to 0, so you wouldn't add the second parameter. See, that's a 0. See, this part is 0. But for females, it would be equal to 1, which means that we would be added on 62 to get the model predicted on female. Notice that, however, that now the parameter estimate for B1 would be negative. 62 plus minus 6 would yield the mean for this one, which is 56. See, look at what happened over here. See, 62. This is where the 62 coming from. That's 56. 6 plus 62. Is the typo? Let me check. Then, because the males are coded 0, x would be equal to 0. Okay, in the male, if you use that model for the males, you're going to use x equals 0. So you would not add the second parameter. The second parameter go away. For females would be equal to 1, which means that B1 would be added onto 62 to get the model prediction for females. Then, however, the new parameter would be B1 would be negative 62 minus 6, which is the female 50. I think it should be 65, this one. This one 65. I think there's a typo over here. Doesn't matter. Then if you want, you can go with the 62. But they were telling that instead of using this one, see. So this is y equals b naught plus b1 x plus e. Okay, I'm going to take only this part for my convenience, and then that's the part that we call the y hat actually. Okay, like this. So if you get this one, now this time I'm going to say this is for males. See, the males is going to be 65 plus b1. See, and this one b1, whatever the value of b1 is, it should be negative 6. I'm going to put 0 for this one. See, you get 65. Then for males, for females, I'm going to write the same thing, b naught plus b1 x plus e, but I'm going to take this one y hat part only. Then y hat equals b naught plus b1 x b naught 65 plus b1 is nothing but minus 6. This is 1. That's how they get a 59. See, either way you're going to add. This time it's going to be subtract. Okay, that's why it should be 65 and 59. I think I made a mistake. Okay, so again, see, then again, say in the empty model, the predicted score is nothing but y hat. It's the grand mean. See, y hat predicted score, they denote by y hat. Grand mean denoted by y bar. In the sex model, the predicted score is y hat again. See, the mean and female group of the mean, sorry, is the mean or female group or the mean of the male group. See, that's the, see, mean of the female group or the mean of the male group. See, anyone can be easily calculated. Now let's see how to fit in this model. See, it's very easy. See, fit in that model with the explanatory variable, which is, we discussed that how this is going to work. Here's the model we are going to fit. B naught b1 x plus e. We parts of this one is the, see, each person, see what part are different. See, what parts of this equation are going to be different of each person. See, y is going to be different. Thumb length x is going to be different. Error is going to be different. From person to person, error going to be different. Person to person, that gender different. See, so these are the different ones. What part of this equation are going to be the same for each person? This is not going to change. This not going to change. Parameters not going to change. Those statistics not going to change. See, this, let's fit this one into a tiny data model. Very easy. Instead of putting null here, you put the gender. That's it, and then we call that one. Now this time you're going to get the two values. See, Intercept will give you that your B0, this B0, this B1, they're going to call the sex male. That means in the gender, how much you have to add to this guy, to females, to get the males. That's what they say, sex male. So this one, 59, is the average of females. This is another way that how much do you have to add to this one, add to this guy to get the average of the male thumb lengths. That's what they say with this page, gender male. This B0, this B1. See, how we're going to write. How the elements of the equation in a linear map onto this gender model. See, this is Y. See, this is mx plus b. This is same like a representing that what, the straight line or something like that. Okay, so they're gonna match. M stand for like a Y for this one. B naught is this is what they were talking about. They say this is same like a something that you have seen in mathematics classes. See, when you take the math classes, you have y equals mx plus b. Same thing I'm gonna write. See, you can write b plus mx. So in our model, y equals what? B naught plus b1 x. So x to x, m to this one, e naught to b, y to y. It's the mathematical model. Math model. This is a stat model. Stat model. So they say how they connected. Y means y. B naught means which one? B. B1 is what? M. X equals x. Okay. So now we see, I'm gonna save that one to something called tinysex dot model. See, and then you call it, you get this one. See, get this one. So map the terms to the element of this one. Y is the thumb length. 59 is nothing but the female mean. 6 is that increment to add on for females. See, that's the increment to add on for females. See, that's how much you have to add to females to get the male's thumb length. X means this gender. E means error. See, if 6 is the increment you need to add on males, then how is X coded? 0 for females and 1 for males. If you want to do like that, if you want to add, if you want to subtract, you do the other way around, okay? If you want to subtract, you're going to put the 0 for males and 1 for females, okay? Let's go ahead and do the same thing for that complete data set. Then save to this sex model, not the sex, tiny. This one say tiny sex. This one this one this model. Same thing that we can get it over here, and we can do some small changes. See, look at this one. This one right. This one just the fingers. See, same y tilde x. As I mentioned in the very beginning, anything before tilde gonna go to y. Anything right after tilde gonna go to x axis. If you run, see, you get 58.256 and 6.447. See, if you run like that for the whole data set. For the whole data set, it's slightly different than you have a 59 and 6. This is B0. This is B1. Consider this model. Now take a look at the estimate of filling the model with this one. Thumb. This one is how much? B0. This is B0. 58.256 plus 6.447 times x. And then when we have a model, if somebody gonna add into this data set by looking at their gender, if you know that whether they're gonna be that male or female, based on that one, you can predict the thumb length. That's like a very fair prediction, very reasonable prediction, because it has been built up based on this given data set. Plus that abstract part, the model has been built abstractly through the mathematics. Okay. See? Like that. Now let's interpret our fitted model. Okay. So they say, what does that 58.26 mean? 58.256 means, see, this number represents the mean thumb length for female in fingers data. This number is B0. See, all the options you have to pick. See, this is nothing but y bar f, y bar, see, subscript f. Okay, this is B0. 6.45 mean. This number represents the increment added on to estimate the male thumb length. Or this number is P1. See, you know that. How is X coded? 0 for females and X for males. See? Why are these parameter estimates different from the ones we found for the tiny fingers data set? Because this one estimated from a different set of data. First one, we did this one from fingers. Earlier, we did that one from the tiny finger. So definitely, the V0 and V1 gonna change for sure. Okay. Okay. So as I mentioned, this is the right way of writing without error. This y hat is nothing but 59 plus 6. Why do we leave out the error term when trying to predict? Because we don't know how far off the new observation is from our model. We can only find our error in, see, inside, see. Error is whatever is left over from the model. When we use our model to predict, we are focused on using the model. See, that's the reason. Only the model part. We don't need that error term. We want to predict. You get this part only, model only, because every person will deviate a bit from the model in different ways. That's right. Because of that, so all these will be considered. Look at this one. See. Now what we leave out the error term because this takes a model as its input and then return as a project that work as a function. To use the function, you have to save it somewhere. Do that for you using the following code to create a function. Tiny, see, gender.fun, see, make fun. This model, as already they have run this model. Okay. Let's see. What are you gonna get? 65. That means if you know that see, this one, see, I'm gonna say here, see, error because of the every person will have, okay, this prediction is easy to use. If you want to predict what the next observation observed thumb length will be, we can see that if the next student sample is female, their predicted thumb length is 59. If they are male, the predicted number is 65. It is not that hard to do this in your head, especially for a sample model. But of course, we wouldn't do that one in our head for more complex model. R provides a way to turn a model into a function, see, which we then can use the predict future observation based on the model. It's called the make function, see. You're going to convert this into a function. When you convert this into a function and then save to this one, whenever you're going to say that value give for x, okay, they're expecting you to give the value for x, that would going to give the value for y. That's called the function, see. So this one is, see, that you know that mathematically, but how could that? We know mathematically it's going to be like that, but this the computer doesn't know. So you have done, let's say that in a certain way that see this one tiny dot, sorry, right here. This is what we had in the beginning. Tiny dot model means you have run linear model on Y means thumb, okay, tilde, gender, okay, data set, tiny fingers data, close it. And later on that model, okay, you're gonna make a function. This model not enough for you to do the calculation. Otherwise, you have to do calculation by hand. You're gonna convert this into a function. See, make fun. See, here make fun. See, get this one tiny x dot model and convert it into a function and save to something called tiny x dot. Not the model. I'm gonna call this one function. See, function. See. Then for inside this function, okay, it has all the time, since it's a function, it is a function. For that one, you don't have to give anything except for that whether that person is male or female. That's all the only thing that they were expecting, X value. See, they are expecting X value. See, they are expecting only the X value, and the rest would be calculated by the computer. Okay, so what we have to do is, let's say that for this function inside the argument, I'm gonna give the male. The person is male, is going to do the calculation and say, hey, y hat is nothing but b0 plus b1x. Okay, male means x equals 1. Okay? He knows that one. b0 is 59. This one is 6. This one is 1. 65. See, it's going to do that one for us. See, that's how we got the 65. See? We converted that model into a function. See, the model into a function now. See, but for the function, you're supposed to give the value for x only, because we have only one x. That would give you y as your output, which is 65. See, like that. See, what input does R want from you in order to compute? See, what input is expecting? X only. So inside this function, see, you put the input. See, there's the name of this one is X. And your input would be, see, gender, male or female, equal sign. Okay, see, those are called the inputs. See, these are inputs. See, and once you do that one, you get the output, either 65 or 59, based on whether you have. We're going to enter that x equals 0. Input would be, he's looking for input is nothing but x equals 0 or 1. See, he will do the calculation by itself. You have to give the male. Male means male being denoted by 1. They know they're going to put that 1 into your equation and calculate and give you the answer. Okay. And if it is female, then it's gonna take the x will be replaced by 1 and then do the calculation, and it's gonna give the output as 59. What is the output of this function? Output is given by y hat. We know that one. Now try creating a function-based 6 model. Move it to the large one. Okay, see this one. You can say, see, you're going to convert this into a function. Before that one, you can remember that how we got this one. See, you got this one. We don't need to do that one. They say that we have a the other model. Yes, dot model we got by running linear model for thumb, tilde, gender, data, fingers for the full data set. Okay, it's already done. Okay, I'm just typing for you. Now they say, oh, I don't need a model, I need a function. So you're gonna make function of that to convert into a function and then calculate for the gender. Anyhow, that you don't need that one. Oh, which one is that one? Oh, variable sex, not a gender. No. See, 58. See, this one for the female. Female, you got the 58, 22.5. This is the value eventually you're gonna get. It has been converted. This part we don't have to run. It's already run. See, 58, 25.5. That is the female, the thumb length for female. The predicted value. See how to get the predicted value now. See, you can remember we used that function. First guy, female, female, female. They're not going to take the grand mean this time, okay? They're going to go ahead and then take their mean. See, that's their mean. And the other three going to take their means, males. See, that's what you're going to have from the prediction function. See, the predict. Predict means if we haven't collected data, what would be the thumb length for the first individual? Since first individual is a female, we can consider very fairly or reasonably, we can consider that length should be the average of the female group. See? It's a fair approximation. See? That's what we call the prediction. In addition to that, we can predict about somebody that who's going to be added to this group, like let's say the seventh person. By looking at the seventh person, how could we know that his thumb length is going to be 59 or 65? It's very easy. Then you know that whether the new person who will be added is going to be that male or female. If it is male, it's going to be 65. If it is female, it's going to be 59. You know, that's a different kind of prediction. Okay. Now let's say that you want to save this predicted value for each person as a variable called sex predictor. See, it has been saved to within that tiny fingers data set, but for the new variable called the sex dot predicted. So that means this will be run and then save to that guy and run tiny fingers. See, it has been now added. See, even though it's 56, they're assuming that if that data set has not been taken, then 59 would be a good prediction or estimation value for the first individual. So female, and then that one. Okay. See, what's the difference between the function that we made, times x func, and the predict func? See, predict can only generate predict scores for the data you use to create this one. The input predict is a model, and the input time is a value of explanatory variable. See, input the predict is a model. The input to this one function is a value. See, this will give you value. This is going to give you function. See, so it's a model. That's the model. Predict means the model. You're going to calculate the model here. Here just see the input to this one is a value of the explanatory variable. For this one, you're going to put a model here. But if it is the function, the times x function, then for inside you're going to put a value for the explanatory variable. Okay, that's what they say here. See? So the predict, this is what they were talking about. If you use the predict, see, for predict function inside, you have to give the model for sure, whatever the name of the model. If you use the make fun, whatever that make fun inside, see, You give the here model again, see. But when you save this one to something and then save this one, see, how could you gonna? This one is a function. See, this one you cannot take this one as a function. This is the function. See, then you're gonna say this one can remember they have their names. See, times x1. See, I'm gonna write 9x1. The other one, see, these two. That's why he's asking that when it's come to this one, this one is gonna give you. You have to for the inside. See, if you go to tiny x, this one inside here, you put a value. But if you come to predict inside for the argument, you put the model. That's how they say. So that's how they differ from each other. Times x, this one going to calculate the value for that particular model. Okay. Now we say to try the function predict on the full data set. Recall that you feed the model to the full data set fingers. You save the model as x.model. Now see if you can generate prediction from the model and save the prediction as a variable in the fingers data. See, this data, this has already run. See, it means saved to this one. Now you're going to put this back into this one. See, generate all the possible prediction. So that means this predict function. See, I'm going to get this predict and copy and paste here and then make this one and take the select on the finger, sex, thumb, sex predicted, comma, 10 entries and take the head. Only 10 head. This time we have the predicted for the whole data set. And put it back into this data set again. See, this one is in millimeters because of thumb length. Okay, can you remember? These are the see. The output is a thumb length for sure, all the time thumb length. See, this one y hat. Y hat means the it's predicted value. Y means that's a regular value. That's a real value. It's the real value. This is the data. It's the predicted value. They have a gap. They differ from each other. See, look at this 66, but it has been predicted 64. It should be 64. Now it's been predicted 54. 58, sorry, 58.255 or something. Look at the gap. The gap between thumb and the sex predicted, that means the thumb length for that particular model still have a gap. See? That's called the error, residual. See, you know that one. Okay? See, now you can calculate the residual from the model, as I mentioned over here. See, for each one, see, you can calculate the observed value minus the predicted score. Observed value minus the predicted score. Or, see, for each person, y minus y have each person observed minus predicted value. Same thing. See, this one minus this one minus this one. See, that's why I say go to the tiny fingers, and then you're gonna call its name is resid. Tiny fingers thumb, go to the thumb, and go to the predicted value, and that would give you the gap, which is deviation residual. See? So why in the first line the data is 6 resid minus 3? Because that is the value of 56 minus 59. See, it's minus this. It is below its own average. This value is below its average. This value is again below its above its 1 unit average. See? 1 unit, 2 units above that average. Here, this would be that 2 units below the male average. This one is 1 unit below the male average. See? This one 3 units above the male average. See? Why do all three females have the same score? Because it's a predicted value, prediction. See? All have the same value. That's the average of them. If these data not been observed, this would be best estimate or prediction for the females. Females, and on average, you can say their average would be the best number that you can best thumb length. Okay, so does it this males. Instead of doing that one, now you can calculate the receipt using the receipt function. See, go to the model and get this one. Now you're going to call that on receipt 2. See, this is the first method that you found this one by taking subtraction. I mean, manually you gave the value, but a program going to run for all the data entries, but you manually entered. But here, you don't have to do anything. You just recall that one and say, hey, they give the function and say, go ahead and calculate receipt of this data. We'll calculate same thing and put it back into the data set again. See, the receipt function in R computes the residual for all the observation in the data frame. Takes the model and compute all the residual or leftover variation. See, leftover variation. It's called the leftover variation, residuals, leftover variation. Okay. So see, finally, let's compare residual from the TinySeq model to those from the TinyMT model. See, that's this is the model. Residual from coming from this model will be compared and contrasted with that coming from the empty model, but the same kind, 6 entries. Okay. And let's first add variable called empty. See, pred using the prediction function and print tiny fingers again. See, prediction, predicted value for the tiny fingers and empty pred. See, empty pred. See, it's the pred value. See, but that's not for this sex model or the cisgender model. As for that empty model, tiny. See, this model one, I'm going to add to here. Okay. I'm going to include another one and see, look at 56, its predicted value 59, empty model. If this gender has not been included, it should have been 62, 62, 62, like that. See, why does everyone have the same score for empty? Because there's a tiny empty models prediction for every person's thumb length, every person's thumb length. We're not going to take into account whether the person is male or female. We're going to overall, it's called the empty model. In the empty model, 62, 66. See? Then empty model has a residual too. Look at what happened. See, that model residual. See, that's the kind of a discussion we built in up here. See? So see, now we can say that create a new variable for tiny fingers, data from empty, see, empty receipt. It's called the empty receipt, and generate residual from tiny fingers. See, you can just say this guy. Receipt. Get this one. Sorry, not the TinySeq model. It's an empty model. Here's tiny empty model. Okay, empty model. I'm gonna find the residual. See, the code to tiny fingers. See, tiny fingers. We calculate that this particular model, that the model that we are working on, categorical model, group model, see, based on the group model. So this is the data. Okay, it has to do nothing with that model. The model predicts the way that we set up B0 plus B1x 59, 59, 65, 65, 65. With their difference called the residual. And we calculate residual another way. Then we went to the empty model. Now we calculate its residual. See, with respect to that one. See, this is what we were talking about. See, that means that if you're going to go ahead and see, as I mentioned earlier, see, so you will see, this one, see, you have its mean, this guy's mean, this is for the female, this is for the male, then X would be your gender, then Y would be your thumb length, then you have a grand mean, Y bar, which is 62, see. So if you pick up this guy, let's say somebody from here, let's say that first entry is 56, okay, for female, 56. See, 56 can be explained by two models. See, I can explain by, see, I have two models now. One is called the empty model. The other one is see, this model. See, or we can say the two-group model, or we can say another name, two-group. Some word I'm going to use for the first time, regression model. See, regression model. This model is nothing but y equals y bar plus e. See? And y hat is nothing but y bar. Here this is nothing but b naught plus b1 plus, other way what you can say, b naught plus e, b1 plus e. Therefore y hat would be b naught plus b1x. That's the model part. See? So this is nothing but y hat is nothing but y bar female plus y bar male minus y bar female times x. See? Another way of writing that. See? So there are two models. So that with respect to this guy, with respect to this y bar f, which is 59, this gap, if you calculate, this is my y. I'm going to say y minus y bar f. Y is 56 minus 59, which is negative 3. Okay, that's for this X model or two-group model. Same thing I'm going to calculate with respect to that guy. See, you can calculate then y bar, y minus y bar, which is 62 minus 56 is negative 6. Look at that. That's negative 6. That's what they say, that this line. See, this line I'm talking about first one, see, negative 3. You can get this done in 2 ways. It's a different thing than the negative 6. With respect to empty model, see, if you measure this one with respect to this one, this minus 6 came with respect to empty model. Empty model. Empty dot model. That's what they say. See? Calculate the residual. See? See, compare the two columns of residuals, X residuals and the empty. See? Empty residual and either. See? This one. See? Minus 3 minus 6. This one 1 minus 2. 2 minus 1. See? What is the difference between X residue and empty residue? Check all that apply. See, X residue is the leftover variation from the sex model, but the empty model is leftover variation from the null model. This is the unexplained in another way, the variation coming from the empty model. See, that's what they say. Okay. See, leftover variation. See, these are the leftover variations coming from that model. See, empty model that cannot be explained. This cannot be explained. Unexplained variation from this one. It will be brought to the other model and then explained. When you try to explain, when you try to include that as gender, it has gone down. See, gone down. -6 become -3. See, -2, 1. See, this one, this one going up this way, but so the unit wise, if you get the unit wise, see, this has gone up. See, this is unit wise gone up. See, this one gone. See, again, -2, -1, 3. See, this down. This is down. Okay. See, leftover variation from the sex model, but the empty model is leftover variation from the null model. Represent the residual left after subtracting out the sex model, but empty resid is a residual left after subtracting our null model. See, we know that y minus y bar in one case, the other one, in order to find the error, you subtract y minus y bar. Y bar means like a y bar f. Okay, I'm talking about this gap or this gap. Y minus, see, y bar or y minus y bar f. See, that's how you got those two. But model has more error around it. See, the empty model, because the residuals are greater in extent from the model. See, definitely it has a more error. That error has to be minimized. That's why we are trying to include that gender. Okay, that's good. Okay, so see, in the following window we have provided the code to, I'm sorry, graph in residual from the model. See, you might wonder why are we bothering the generator and save residual. We will have a lot of way to save this. So what we're gonna do, we get this residual, store the residual from this full model. Okay, full model. This is already run. Okay, the full model, not the tiny fingers, but the resid for this one. Okay, for full. Resid for, get rid of this one. The timing. That's the sex model. Okay, so the full data set. See, it has already run, and then they call that a sex model. For that one residual, you're going to send them, and then if you run, see, you can see they are residual. I'm going to read 10 entries. See, sex received. The following we will provided the code to create the density histogram in a facet grid by sex. The modifier needs to generate density histogram. Sex receipt in the facet grid by sex. Compare the histogram. See, GFD histogram, thumb, this one, see, facet grid. So this one. Thumb and this one. And then we're going to change that one to see. We don't need that for the thumb length. See, the histogram has been drawn for thumb length, and in order to get the facet grid, it has been faceted. See, with the gender, see, data, and then faceted in vertically. See, vertically for the male and female. And what we're going to do, instead of drawing the histogram for this one, we're going to draw the histogram for the residual. See, okay, the data set would be, we're going to do this one, histogram for X. dot resid. Data fingers and yeah, it has been done. I'm sorry. Say here over that one. You're gonna do the same thing for the residual. See, this time for the residual. That's why it has like a 0 in the middle. See, what do you note about these two? In the histogram, it seems like the males are shifted higher than the female, but it's not true in the sex resid. See, when it comes to the residual, you don't see such a difference because everything has been centered around 0. But here, not like that. If you go ahead and then get the mean, here 0 or the here 0, both cases it's going to be 0. Male or female doesn't matter for for residual, but for the Y, see, the male thumb length are say average thumb length is higher than that of the female. See. That's why we are trying to see draw the line and see. As I mentioned earlier, that I think we have very clear idea how to draw this one. See. This is gonna be like a 65. This is 59. This is 0. Always 0 for the residual. I mentioned that one. See the same thing. See, this create the histogram with the line at the mean thumb length for the each sex. See, thumb stats, favorite statistics you get for the full data set thumb histogram. See, then you're gonna draw this one thumb data fingers mean color from this. See. But why they not gonna show the vertical line? What happened to the vertical line? Yeah, there you go. So vertical line. Okay, we have to add that one. This line. Okay, 0. So then this one, I'm gonna link. Okay, link this one. Control V intercept. Then you can see the mean of not that one, not the thumb stat. It should be that average for those values. Okay, we can give another name for the favorites. Let's see this one. See sex dot favorite statistics. This one. See, that's for that. See, favorite statistics. For this one, data fingers. Oh, why average? What's the average? Okay, let me see what happened. Here we have provided the code to add mean lines for each sex group to the thumb histogram. Modify the next chunk of code to add mean lines for sex group to the sex resid histogram. Okay, sex resid. This one, see, by gender. Okay, this one also by gender, data, fingers, histogram, sky blue, facet grid, x-intercept. Thumb stat, here is the problem. Okay, it's another thumb stat. It's called sex resid stat. Sex resid from that, see, this one considered like a data set, that data set. In that data set, you can ask for the mean. See, spin shift. See, always say previous one is this one. See, so you should know how to put this one. We have done this one in so many times in large scale. Okay. So they say about the histogram of the residual in the y are the means. See, is it for the two groups not different anymore? See, in the sky blue, y are the means of sex resid for the two groups are not. They're not different from, see, anymore. They look the same. Because the residual are what is left over after subtracting the means of the two sex groups from the original thumb lengths. That's right. Because the residual are what is left over for taking out the effects of sex. Because of the residual of what is left over accounting for variation in gender. Because of the residual of what is left over modeling the data with this model. Because of that, we introduced this model. See, because of that, the residuals, see, residuals for the male and female, see, gonna be the same. See, that's what they say. See, residual. Why are the means of this residual for this particular model not different anymore? See, with the residual of what is left after subtracting the mean of the two sex groups from the original thumb lengths, and they will be subtracted. See, residual are but not from the grand mean. This is what I'm talking about. This is what they say. They say that not because of this gap, because of these gaps, because this gap residual are the deviation from their own mean, okay, their own mean. See, so their own mean. So that we not gonna consider. If you go ahead and look at that, all three members over here, I'm not gonna take into account the grand mean. I don't need that one. I'm gonna go to look for the 56 and whatever that, let's say 60 and 61, those for the female thumb length being given to us. Based on that one, I'm gonna calculate its average. I'm gonna calculate the residual for each and every data point, like a 56 minus 59, 60 minus 16, 59, and 61 minus 59, and those residuals, and then add together and divide by the 3 would be 0. And I do pretty much the same thing over here, because then I'm going to calculate the deviation of the residual, not with respect to this guy. There's no such thing. Residuals are calculated with respect to their own average. So because of that reason, for this group or this group, doesn't matter, regardless of the type of the group, you're going to end up with 0. That's what they say. 0. See? Because the residual are what is left over after taking out the effects of gender. See, because the residuals are what is left over accounting for variation. See, it's gender. See, and because the residual are what is left over after modeling the data. After modeling the data, you took that leftover. Because of that leftover will give you the 0 error, because that all the error of the terms are, see, error terms are centered. So I mean, like the balances, all the residuals, all the residual coming from that model are balanced by 0. Okay, balanced by 0, regardless of that. And that's what they say. About that Instagram, the residual in the sky blue, why are the means of both the two groups equal to 0? See, that's the same thing. Okay. Not different, it's the same thing. Kind of like that. So what I'm gonna do, I'm gonna just, because since we have like a plenty of time to that cover, even on Thursday, this is the only chapter, I think we can stop over here, and the rest we can cover on Thursday. See, and if not enough that I can even that see, this one I can cover. Okay. Little bit today I'm gonna little bit stop a little bit earlier because then because we have plenty of time so that cover that rest of the chapter. Okay. If you have any question that we can discuss right now, that if you have anything you want to discuss, or that you can see me after the class and then discuss too personally. Just if not, I'm gonna wind up over here, and then I'm gonna because the rest I can cover that Thursday, plus that if even that that particular time not enough, I can make another video and then upload to the system, and then we're gonna have, I think if you don't have any question on your homework, quizzes, midterm, final exam, and all the courts and all these things, I'm gonna wind up over here, and then yeah, I'm gonna keep the office hours on Wednesday as well too. See, make sure that I keep the office hours every day, but no one showed up. Okay, so please that if you have any question, you can just appear. I think April came. Yeah, several. He came. Yeah. You came several times. Yeah, I think, but we didn't get a chance to that go through that anything in detail, and I can help you out to that finish you all that if you guys come, that all the homework, quizzes, and then compare and contrast and see that for the quizzes, that what kind of a mistakes you have done, then this midterm test and the upcoming final exam going to be that definitely that chapter in review section. It's from the chapter 7. Okay, so it's going to be it's not going to be hard, it's not going to be cumulative or anything. It's simply that based on chapter 7 or that the chapters that I'm going right now. So if you guys don't have anything, I'm gonna wind up. I'm gonna stay for a while to that meet some student, and then I'm gonna let the other student to that good night, and then have a wonderful day, and then stay safe and be well, and then see you guys either on Wednesday or Thursday. Okay, see you then. Good night. Yeah, sure. Yeah, sure. Thank you. Good night. Okay. Good night. Thank you. Good night. Hi, Brick. I,
Hi, Sumit.
hey, how are you? Hey,
Thank
then I was looking at the homework. What happened? I think there's a misunderstanding over here. That I think the first time you did right. That's why I think question number 8 and 11. I pulled that out. It
Was it
seems
the midterm or the assignment?
homework 2.
Oh, okay, homework two.
I think that no, sorry, the last one that you turn in that midterm,
Tomorrow?
no, midterm. I think midterm,
Yeah, midterm.
midterm. Sorry. Okay, hold on. Okay, what I'm gonna do? I'm gonna get this pull out, and then I'll show you. Uh, okay, you did really good, but I think there's a small misunderstanding. That's
Yeah,
right.
I think I was confused with some of the questions,
Yeah. Okay.
and then it wasn't coming out right when I was putting in the R code.
Okay. It's midterm. Yeah, midterm. Okay. Sorry. I'm gonna open this one. The one that you just sent me that I started. I'm gonna pull out the boot. Okay, this is the one that you had earlier, and then we had a. You fixed that one. I can remember here. Yeah, okay. I think there's a slight misunderstanding here. Okay, I'm
Yeah.
gonna. Sorry, I'm gonna. Before that one, sorry, I'm gonna just. I'm gonna end this recording.